Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a long video format discussion on college algebra. Okay, let's proceed. This is a continuation of my long format discussion on college algebra. This is now lesson number 22. Okay, let's proceed. This is lesson number 22. The subject matter is long video format discussion on college algebra. And the title of the topic for this morning will be fractions. Okay? Or the more complicated equivalent of fraction is rational expressions. This is part 1. So the topic for this morning in layman's language will be fractions, part 1. Fractions. Lesson number 21, we deal with the so-called special products and factoring. So we will now apply our knowledge of special products and factoring to the so-called simplification of rational expressions or fractions. Or that involves a complicated thing, a polynomial over a polynomial. A polynomial is actually an algebraic expression that contains so many terms. So in the so-called simplification of that one, okay, there will be a rule on how to simplify a polynomial over a polynomial. Okay, and the concept on how to simplify, this is the concept, how to simplify. Factor the numerator and denominator, then cancel out the common factors. So fractions, it involves a numerator plus a denominator underneath. Okay, and according to the concept, cancel out the common factors, cancel out. So how could we cancel out? So we try to, what you call this, apply our knowledge of special products and factoring. If that given polynomial is in the so-called expanded form, try to factor out by using your knowledge of special factors and factoring. Okay, let's try to bring out an example problem so we could visualize how to simplify a fraction which involves a polynomial over a polynomial. Okay. Simplify the rational expression. Rational expression meaning we are given a fraction. Okay, that's why I give you the title of the topic for tonight. In layman's language, it is just plain fraction. Rational expression, okay, if you didn't have or you didn't study formally algebra, you will not know what is a rational expression. Okay, simplify the rational expression or fraction. We are given 16 minus p squared over a p squared minus 8p plus 16. We are asked just to simplify this one, okay? In according to our concept, okay, try to express the numerator and denominator as a product of special factors. If it could be factored out as a special factor, do it. Okay, let's proceed with the solution. We'll do it separately. 16 minus p squared can be equal to negative open quantity p squared minus 16 closed quantity. Okay, I bring out this negative sign, then I will try to multiply this by a p squared minus 16. A negative 1 times p squared is actually negative p squared. And a negative 1 times negative 16 is actually plus 16. So this one can be written as negative open quantity p squared minus 16. And luckily, from our study of special products, p squared is actually the product of two binomials, which is sum and difference, right? Two terms, it is a binomial preceded by plus. Two terms also preceded by minus, okay? Connected by a minus. If we try to expand p plus 4 times quantity p minus 4, it will be p squared. Middle term will cancel out because it is 4p minus 4p. It will be 0. And the pure constant will be plus 4 times negative 4, that will be negative 16. So the equivalent of 16 minus p square will be negative open bracket. Okay, since there is a negative sign over here, I want to enclose the whole thing with the bracket. Times the quantity p plus 4 times the quantity p minus 4, close bracket. That's the equivalent, or what you call this, special product form of the given numerator. For the denominator, p square minus 8p plus 6p. Again, the left hand side is an expansion of the square of a binomial. That is, p square minus 8p plus 16 can be written as p minus 4 quantity square. If you try to expand this one, the first term will be p square. The middle term will be minus 4p times 2, that will be negative 8p. And the pure constant will be negative 4 quantity square, which is plus 16. So p square minus 8p plus 16 can be written as the quantity p minus 4 quantity square. Okay? So we have expressed already the numerator and denominator as a special product form because we put a quantity, right? So what will happen? Rewriting the given expression or fraction, and they should not be equal to, substituting values. The simplified equivalent of this is negative open bracket, quantity p plus 4 times p minus 4 close bracket, all over. P square minus 8p plus 16 is the product of p minus 4 times quantity p minus 4. Okay, so the operation on the numerator is all multiplications, and the operation on the denominator are all multiplications, so we are free to cancel out. This p minus 4 cancel with this. What remains? What remains on the numerator? It will be negative open quantity p plus 4 all over. The bottom portion, we eliminated 1p minus 4. So what remains will be p minus 4. So to look for the answer to look handsomer, right? We will put the negative sign down. So the numerator will remain p plus 4. It looks handsome, right? We put down this negative 1, we multiply it by this quantity p minus 4. So negative 1 times p will be negative p, right? And a negative 4 times negative 1 will be 4. So our final answer will be the ratio p plus 4 over 4 minus p. And this is it. That will be our final answer. Okay? So we actually follow the concept. Try to simplify the numerator and denominator, okay? Then try to cancel out common factors. That's what we did over here. So after the cancellation, our final answer will be p plus 4 over 4 minus p. Answer. Okay? Oh, what's next? Okay, we'll discuss multiplication and division. We now know how to simplify fraction or rational expression. So we'll now go with the multiplication and division. And this is actually a very important thing. Whether you are simplifying a rational expression or fraction, which contains maybe a polynomial over a polynomial, or just plain numbers, actually the rule is the same. So let's proceed with the multiplication and division, okay, of fractions. So this is the form. We've been seeing this concept here on the shorts videos. My co-bloggers try to bring out some simplification of fractions, and the rule and how to simplify those ones are these. Okay, let's proceed. For multiplication, if the ratio a over b multiplied by, this is that, considered to be multiplication times c over d. if we try to take the simplification, since the operation is multiplication, numerator times numerator, so that will be AC. The common denominator will be the product BD. So the product of A over B times C over D will just be AC over BD. Okay? Straightforward. Just multiply the two given numerators. That will be the overall numerator. And multiply the given the denominators. So that will be the overall common denominator. That is for the operation multiplication. Right? But for division, it is a little bit complicated. It is not straightforward. If we are given A over B, and we divide this by the fraction or rational expression C over D, the simplification will be A over B. We will just rewrite the first fraction, and to change the operation from division to multiplication, okay, we will invert, okay, the given denominator. So the inverse value of C over B will be D over C. It is now D over C. Because C over D, if we try to take the reciprocal, this is 1 over C over D. What will come out will be D over C. So this is now D over C. So to change the operation from division to multiplication, we will just rewrite the first fraction, okay, then multiply the inverse value of the value C over D. And the inverse value will be D over C. Then after that, it looks similar to the first form. So the resulting simplification will be the product AD, okay, all over BC. So for division of fractions or rational expression, it is more complicated because you must have to invert the given denominator for the operation to change from division to multiplication. Okay, let's give an example on how to multiply and divide so we could visualize our concepts. Okay, example number 1. Perform the indicated operation. Okay, indicated operation meaning we are given a first fraction and the problem is asking if we try to multiply this first fraction by the second fraction, what will be the result? Okay, this is that considered to be multiplication. Okay, let's try to bring out the solution. Rewriting the given first fraction, that is 5y minus 20 over 5y plus 15. The operation is multiplication, right? Times 2y over y minus 4. They should now be equal to. We'll try to simplify 5y minus 20. 5y minus 20, there is a common factor 5 multiplied by quantity y minus 4. So 5y minus 20 can be written as 5 times the quantity y minus 4. Because 5 times y will be 5y and 5 times negative 4 will be negative 20. So 5y minus 20 can be written as 5 times the product of quantity y minus 4. The given denominator is 5y plus 15. There is also a common factor 5. We bring out 5. So this is multiplied by the quantity y plus 3. Because 5 times y will be 5y. 5 times 3 will be 15. So 5y plus 15 can be written as the product of 5 times the quantity y plus 3. The operation is multiplication, right? Multiplied by 2y plus 6. There is a common factor 2. We bring out 2 times the quantity y plus 3. Because 2 times y will be 2y and 2 times 3 is 6. So 2y plus 6 can be written as the product of 2 times the quantity y plus 3. All over, okay? The given denominator is actually just simply y minus 4. So we already expressed the first fraction and second fraction, okay? The operation is multiplication, okay? As a product of its prime factors maybe, right? Then according to our concept, try to cancel out common terms. This y plus 3 cancel with this. This y minus 4 cancel with this. So what remains on the numerator will be, this will now be 1, this is 2, this is 1, the operation is multiplication. So what remains on the numerator will be 2. And for the denominator, there's a cancellation also, this 5 and 5. Right? So what remains on the denominator is the product, this will now be 1, okay, times 1. 1 times 1 is 1, so this is actually 2 over 1, or our final answer will be 2. Okay? So it's easy to simplify, okay, if we follow the concept, because after the cancellation, we could visualize our final answer, and our final answer will be 2. Okay? Last example for this morning before we go for this morning. Example number 2, a little bit longer. Perform the indicated operation. We are given two polynomials. No, two fractions. A polynomial over a polynomial, a polynomial over a polynomial. Polynomial by definition is actually an algebraic expression that contains many terms. So to simplify this one, we must have to apply our knowledge of the so-called special products in factoring. Okay, let's proceed with the solution. Since the given fractions are a little bit long, okay, we try to bring out the, what you call this, equivalence of the polynomials separately. So we'll go with the 16x squared plus 8x plus 1. This is actually an expanded form. And this expanded form is actually the square of the binomial 4x plus 1 quantity squared. Right? Because if we try to expand this one, 4x quantity square will be 16x squared. The middle term will be 4x times 1 times 2, that will be 8x. And the last part will be 1 quantity square, which is 1. So meaning to say this 16x squared plus 8x plus 1 is equivalent to the square of the binomial 4x plus 1 quantity square. Okay? A binomial is a term that contains two terms. Right? Next one. 3x squared plus 8x minus 3. Okay, this is a little bit complicated, right? Because if we try to simplify this one, use your knowledge of special products of factoring. The possible factors of x are actually 3x and x. So this is a trial and error method. And the possible factors of 3, okay, will be 3 and 1, right? Because 3x times x will be 3x squared, and the possible factors of 3 is actually 1 and 3, okay? But let's try to look for the proper sign. Proper sign for us to bring out the correct middle term. The middle term is actually 8x, right? So this should be plus, and this should be minus. So if we try to check the middle term, negative x plus 9x is actually 8x. So the simplified equivalent of this as a special product will be the product of the two binomial of sum and difference of 3x minus 1 times the quantity x plus 3. Right? Next one. 4x squared minus 3x minus 1. Okay. It's the same. The possible factors of 4x will be 4x and x, right? Okay. And the possible factors of 1 will be 1 and 1. But the sign of the middle term is actually minus. Okay. So this should be minus and this should be plus. So if we try to check the value of the middle term, if this is minus and plus, this is x. 4 times x is negative 4x. And the sum of this will be equal to negative 3x. And this negative 3x is same as this one. So the linear equivalent or the product of two binomial of this given quadratic equation is the quantity 4x plus 1 times quantity x minus 1. Okay? Last one. x squared plus 6x plus 9. Oh, this is an expanded form, and this is actually the square of the binomial x plus 3 quantity square. Let's check. The square of x will be x squared. The middle term will be 3x times 2, which is 6x. And the last part will be the square of 3, which is 9. So x squared plus 6x plus 9 can be written as the square of the binomial x plus 3 quantity square. Okay, let's proceed with the solution. We just brought out the special products equivalent of the given polynomials. So rewriting the given original fraction, right? We will rewrite the first one with their equivalence, and we now change the operation from division to multiplication. So this will go up and this will go down. Okay, this x squared plus 6 plus 9 is this one, so it will go up to change it from the operation division to multiplication. And the bottom portion, this will go down, this one, which is the product of 4x plus 1 times the quantity x minus 1. Okay, it looks nice. So actually the operation on the operation now for both fractions is multiplication. So actually the simplified equivalent of the numerator will be the product of this one and this one. The operation is multiplication. So we are free to make cancellation. So this x plus 1 cancel with this. What remains here will be 1. And this x plus 3 cancel with this. What remains here will be 1 x plus 3. So the simplified equivalent of the numerator will be what remains here plus here. So 1 for x plus 1 and 1x plus 3. The resulting denominator will be, this is not cancel out. So 3x minus 1 times the quantity x minus 1. Okay? And to bring out the final answer in the so-called expanded form, just expand this one and just expand this two, the denominator. The expansion of the numerator rather is 4x squared. X plus 12x will be 13x, and 1 times 3 will be plus 3. And the resulting denominator will be a 3x squared minus x minus 4x, minus x minus 3x is minus 4x, and the negative 1 times negative 1 is plus 1. So this is actually our final answer. Okay, in terms of another polynomial over a polynomial expanded form, that will be our final answer. Okay guys, that's how we perform fraction. So the concept of the solution is our knowledge of the so-called special products and factoring. Okay, so for those of you who are starting to study college algebra, this is for you guys. If you want to subscribe to my channel, okay, under college algebra, long video format, you can subscribe at youtube.com/@ProfDavidJ. If you want to share it, please click share, okay? Try to watch my long video format discussions, okay? You will learn something from it. Okay, good morning from Los Angeles, Professor David J.